Hello dear learner, welcome back to the Zoom Chemistry Hub. Today with another interesting and informative video in which we will discuss different types of concentration terms in chemistry. So first, what is concentration? Concentration refers to the amount of solute present in a given amount or quantity of a solvent or solution. This is called concentration. Discuss different ways to express the concentration includes molarity, molality, normality and PPM. And today we will discuss each terms one by one. So first, molarity. It is represented by capital M and it can define as the molarity is the number of moles of solute present in a liter of a solution. Formula. The formula of molarity is M is equal to number of moles of solute divided in decimeter cube or in liter. Now we take the example, how can we find the molarity of a solution? We have an example that we can calculate the molarity of a solution containing 5 moles of sodium chloride in 2 liters of solution. So we calculate the molarity as M is equal to the number of moles which are 5 divided by how much solution or how much solvent in which we dissolve 5 moles of solute, that is 2, and after calculating mathematically we get 2.5. That is the molarity of sodium chloride which contain 5 number of moles and dissolve in 2 liter of a solution, and in this solution its molarity is 2.5. Next, what are the reasons why we use the term molarity? Molarity depend on volume. So the volume changes with temperature. As we know that volume is a temperature dependent, and so since the volume expand or contract on increasing or decreasing by temperature. Molarity is used in aqueous solution and titration purpose. Next term is the molality. It is represented by small m. It can define as the molality is the number of moles of solute dissolved in 1 kilogram of a solvent or solution. That is the we take the number of moles of solute and we can dissolve these number of moles in solvent having in gram or kilograms. Now what is the formula? The formula of molality is the number of moles of solute dissolved in mass of the solvent, in kilogram. Now we take the example, how can we find the molality? Example is that we can calculate the molality of a solution containing 5 moles of sodium chloride in 2 gram of water. Here we have 5 moles of sodium chloride and we have 2 kg or 2 kilogram of water. Now by these two values we can calculate the molality of the solution. By this way we find the molality is equal to number of moles of solute, that is sodium chloride, is 5, and the quantity of water, that is 2 kg, and after calculating these two mathematically we get 2.5 molality of this solution. Reasoning: we know that molality are independent of temperature. Since we know that in the molality we take the mass of the solvent in kilogram, and we know that since the mass remain constant, it is not temperature dependent, so we prefer the molality in the colligative properties calculation, that is the freezing point calculations. Is the normality. It is represented by capital N, and we can define the normality as the number of gram equivalent of solute present in liter of the solution. What is the formula of normality? The formula of normality is N is the normality, and it is equal to the gram equivalent of solute divided by volume of solution in liter. So we can calculate the normality by this formula, gram equivalent of solute divided by the volume of solution in liter. Now we understand first what is gram equivalent weight, or how can we calculate the gram equivalent weight. We know that gram equivalent weight is equal to the molar mass divided by the valency factor. Molar mass divided by the valency factor, and molar mass is the molecular weight of a substance, and the valency factor are the number of replaceable hydrogen ion in acids, hydroxide ion in base, and electron transfer in the redox chemical reaction. This is the valency factor. Now we calculate the normality. We have an example, that is, we find the normality of a solution containing 49 gram of sulfuric acid in 1 liter of the solution. Now the molar mass of sulfuric acid is 98 gram per mole, and its valency factor is 2, because when sulfuric acid dissociate or ionize into their ions, it will dissociate into 2, or it will change into 2 hydrogen ion and sulfate ion, SO4 ion, and here these 2 hydrogen ion are replaceable, which is the valency factor of sulfuric acid. Now we will find the equivalent weight. We know that equivalent weight is equal to the molar mass of a compound or molecule divided by its valency factor. So here the molar mass are the 98, sorry, and its valency factor is 2. By dividing the molecular weight with their valency factor, we get 49 gram. So this 49 gram is the equivalent weight of the sulfuric acid, and when it is dissolved in 1 liter, this is 1 normal solution. Reasoning. Normality used in acid-base reaction and redox reaction. Next type is the parts per million. We can also say PPM. And how can we define parts per million or PPM? PPM represents the mass of solute per million parts of the solution, and it is commonly used for trace concentration in water, air, and soil. And its formula is ppm is equal to mass of solute divided by mass of solution multiplied 10 raised to power 6. By this formula we can calculate the ppm of the solution, that is mass of solute divided by mass of solution multiplied 10 raised to power 6. Now we take the example, how can we find the ppm of a solution. An example, a water sample contains 0.005 gram of lead in 1 kilogram of water. Find the concentration of lead in ppm. We have the formula, the concentration of the solute divided by concentration of the solution or solvent multiplied 10 raised to power 6. So we get mathematically by solving these two, we get 5 ppm is the concentration of lead in 1 kg of water. So by this formula we can calculate the ppm concentration. ppm is used in pollution studies and environmental analysis. Measure very small concentration of contaminants. Final conclusion or final thoughts about these 4 concentration terms. That is, we use molarity when the volume is important. That is, we use the molarity equation in titration reaction or titration process. We use the molality for temperature independent properties, that is the freezing point calculations. And we use the normality in the acid base and redox reaction. And similarly we use the ppm for trace level contaminations of the solution. That's for all today, the learners. If you have any queries regarding this video, please do write me in. Like this video, share with your friends and fellows so we can grow each other. That's for all today. Thanks for watching.